Hey, I'm Daniel with Powell Cams Incorporated. We're gonna do a series. It's gonna be, I don't know, 2 or 3, 4 parts probably. Basically Camshaft 101. Several people have asked, and I get emails, phone calls, with people are asking questions that they don't fully understand, and or they don't understand how things work, and so they need some clarification. And you know, our channel has always been, you know, we want to help everybody understand the subject matter so they can better assess their situation and what they're trying to do or what they need to do and help us get them a better product. So stay tuned and we're going to get into it. All right, so I think maybe the fundamental first thing that we need to talk about is maybe core material. I think we'll start there. So basically, we only do rollers. We don't do flat tappets at all anymore, unless it's like a billet flat tappet, some kind of custom special application. But standard iron flat tappets, we don't do them, so we're not going to talk about them. But in the roller world, you basically have 2 choices. You have, and sometimes you only have 1 choice, depending on the engine application and what kind of core is available for that application. So, you know, I mean, this goes more than small block Chevrolets, but we'll just start with small block Chevrolets because that's what we have the most of in multiple different core materials. So for most street stuff, we try to use a ductile iron core. It's easier for the customer. You can run a standard distributor gear. You can run a standard fuel pump push rod. You know, just no special stuff, right? Then we have multiple different grades of steel camshaft cores. And in the steel camshaft core family, I mean, it starts down as low as like 1050 steel and goes all the way to the other end of the spectrum to like S7 steel or 52-100 steel. So most stuff is gonna be in the 5150 to 8660 window. In that window, and I don't think anybody else does it, but if it's a camshaft machine core, you can get for, well, they actually, I've never seen one, but they do it for small block Fords too, but for Chevrolets, big block and small block, you can get the core with the gear integral, so it was part of the bar stock, or you can get it with a, so basically what they do is they make the core, and the back section, the rear journal and the distributor gear are pressed on, and that way they can use an iron distributor gear, so you can use a standard gear on your distributor and not have to use bronze or steel or any of that stuff. So we refer to those as a 3-piece core, and the standard integral, we call that a 1-piece core. And so I've got and I'll link the video, but I've got a video where we actually change that drive gear on a couple of cores that the gear was bad. Probably the customer used the wrong distributor gear, because most people, when they say a roller core, they automatically assume they need a bronze gear or a steel gear, and they don't know that it's removable and has an iron gear. And so with an iron gear, you have to run an iron distributor gear, generally melanized, With a steel core that's integral, you can run a bronze gear, a composite gear, or a steel gear that's melanized. And we'll probably get into that a little deeper in another video in this series. We'll show some examples and go over all of that. But so that would be your core material deal. And we'll show some pictures of the different steel and iron and how you can tell the difference. I mean, pretty much a cast ductile iron roller core, I mean, it's going to look like a casting. It's rough between the lobes. The lobe sides are not machined. They're a little rough looking. And then obviously a steel core, regardless of its color, steel is steel. If it's fully machined in between the lobes and it's smooth and nice and pretty, I mean, you know you've got a billet steel core. It might not tell you which material it is, but you'll know you've got a billet steel core. You know, one giveaway is if it's copper between the lobes, you know, down in the sections, the spool sections, you know it's 8620. And if it's not gold, copper coated, then you can be sure that it's an induction hardened core, or it could possibly be a S7 tool steel core also. But the S7 is through hard, whereas induction is, you know, it's just got a heat treat layer like the 8620, but generally induction hardened is a deeper heat treat. So having said that, let's move into camshaft lingo, because that's where there seems to be a disconnect, because I get it all the time in phone calls and emails. So the first thing, let's see. Let's just start at the beginning. So we're going to talk about lobe separation, intake center line, duration, lobe lift, valve lift, lifter size, rocker ratio. We're going to try to talk about all of that stuff. So the first thing that I think we'll do is, so I think most people grasp what lobe separation is, but one terminology that we use is, for instance, say we've got a 110 LSA. So how, when we talk about intake center line, this is a movable number, like it's a moving target. When you put the camshaft, so this number is ground in. We set that in the grinder when it's ground, and you can't move it. But the lobe separation, even though we grind, I mean the intake center line, even though we grind in the intake center line, it's still movable because you can use an adjustable timing set to make the intake center line whatever you want it, even if we ground it to whatever. So we talk about stuff, we talk about intake center line, we'll say it like this. We'll say 110 plus 3. Okay, so what does that mean? And again, this is a question that we see over and over again. So what this means is that we have a 110 degree lobe separation angle, and plus 3 means that we have ground 3 degrees of advance in. So if you have 0 advance on a cam with a 110 lobe separation, it has a 110 intake center line. So if everything is correct and you put that camshaft in and you line up the dots and you don't do anything funny with the timing system, then when you degree it, it'll be 110 intake center line and 110 lobe separation. With +3, that's going to give us a 107 intake center line. So when you degree it in, and your cam card will give you this information, and again, you know, I just want to make sure everybody understands, like we have people call and we ground a cam and say it's this, and it says that the intake center line should be 107, and they'll ask, you know, well, do I need to advance it 3 degrees? So the answer is no, you don't need to advance it 3 degrees to get this. This is where we manufactured it. And pretty much across the board, as far as I know, I mean, I can't speak for other cam companies, but as far as I know, everybody, if your cam card says put it in at 107, it was ground for that 107. So basically, when it's saying put it in at 107, that means check it, and it should check at 107. If it doesn't, then obviously adjust the system till you can get it to be 107. And so, and again, I'm gonna give a couple of more examples. I don't want to beat a dead horse, but I want to make sure everybody like grasp what's happening here. So we've got, you know, 110 plus 3, that'll give us 107 intake center line. That'll also give us, so the ICL, that is the abbreviation, ICL, intake center line. Lobe separation is LSA. And then we have, so if we advance if we ground 3 degrees of advance in it, our intake center line is 107. Our exhaust center line now becomes 113. So whatever you do moves both. So this is exhaust center line. All right. So if this was, again, same scenario, we got 110 LSA. If it was +0, then this number would be 110. And this number would be 110. Everybody would be 110. So whatever you move the intake center line is gonna move the exhaust center line the opposite direction. So, you know, take 3 away from the intake, add 3 to the exhaust. Take 2 away from the intake, add 2 to the exhaust. And that's just how it works. It's just basic math. So, so I hope that makes sense, and everybody's got that. So we're gonna clean up all this mess, and then we're gonna move on to some more stuff. All right, so the next thing we want to talk about is, and we're just gonna lay it all out on the board, and then we'll just break it down as we go. But we're gonna talk about duration at different intervals. We're gonna talk about lobe lift, valve lift, and I think that'll be the next step. So generally speaking, we're going to talk about hydraulics and solids. So for the most part, on hydraulic roller cams and flat tappets too, but again, we're just talking about rollers. With a roller cam, and again, this all applies. But so we're going to do hydraulic, and then over here we're going to do solid. All right, so we've got at 6, and then we're going to have at 50. On a solid, generally speaking, you know, everybody's not on the same page. We're going to have at 20 and at 50. So when you get a cam card, again, for most people, or when somebody's trying to sell a cam, or you're trying to talk about a cam, and I don't know why, but every single phone call I've ever got for the last 10 years at least, I can't remember any further than that, but for the last 10 years, and I ask somebody, what's your cam specs? The very first thing they tell me is how much lift it has at the valve. And that is the least important aspect of your camshaft. It's just almost irrelevant. Some people ain't gonna like that, but it's the truth. So when I asked, what's your cam specs, what I want to hear is duration, lobe separation, intake center line, and then you can tell me the lift, but the duration, intake center line, and lobe separation is the most important factors to figure out the valve events, what's happening, what's going on. So, you know, for instance, this hydraulic cam might be at 50, it might be, I don't know, 230. So at 6, it might be, just say 280. All right. So if you have these two numbers and you're comparing some cams to one another, you've got a cam from Bob's and a cam from Leroy's, and you just look it in the book. And and again, we'll delve into this a little deeper further on, but this is just some overview stuff to get us started, so I don't want to get bogged down in the weeds. But say you got two cams, and then let's go down here to lobe lift, and then valve lift. So we got LL and VL. All right. So say this cam has 365 thousandths of a lobe lift. All right. And then whatever your rocker ratio is, so say this was for a LS, so we're going to be 1.7 rocker ratio. All right, we would multiply 1.7 by 365. And I think that's going to come out to like 622 maybe. I should know that off the top of my head. 620 and a half. So that's going to give us 620 thousandths at the valve. All right. So now we've got our system, right? This is what it is. And you should see, again, we give a full cam doctor report. So you'll see on solids, you'll see all of the data at 20 lift, 50 lift, and 200 lift. And on a hydraulic, you'll see it at 6, 20, and 50. I'm sorry, on a hydraulic, 6, 50, and 200. 650 and 200, 20, 50, and 200. That's the way we break it down. Because a lot of engine builders, we look at, to tell how aggressive a lobe is, the simple way, like just with what information you can get off of a cam card. For instance, if you have two hydraulics and both of them are 230 at 50 and 365 lobe lift, and this one is 280 at 6, and Bob's is 285. All right. That means that Bob's cam is slower than my cam. It's moving the valve slower. So when you see a big 6 number, your 50 number is the same, the 6 number is bigger, then it's slower. We would call that the intensity. And again, we'll get into all that too. So on a solid, it's the same scenario. Some people will, I think that pretty much the industry standard is all solids are rated at 20 duration. Some people may possibly actually rate this at lash. So if the cam is, 24 lash or 17 lash or whatever it is, some smaller cam companies may edit this number, but pretty much everybody, all the big companies are using 20 to rate the advertised, right? So on a hydraulic, 6 would be advertised and 20 would be advertised on a solid. So when you see it in the book, like if you get a comp book or something and you're looking at solid rollers and it shows that advertised, that should be at 20, and then most of them will say the 50 also. That information will be in there. And let's see what we want to say about this. So you can be able to just look at this information and figure out, you know, what you're working with, and be able to with some kind of intelligence decide, you know, well, because generally speaking, the smaller this number is and this number stays the same, the better the cam will run. Now obviously I'm sure there's some stuff out there that's not very good designs that are hard on parts, but for the most part, the stuff that's out there today from any reputable cam company is probably not going to beat up parts, especially in the hydraulic world, because the hydraulic lifter is, I mean, it's like a shock absorber, so it's absorbing a lot of stuff, and so you're probably not going to have too much trouble there. Another thing, and you don't normally have this problem, and it's not a big deal if you do, but most hydraulic stuff is designed for a 700 wheel lifter. There are some 750 wheel lifters out there, and it will, because the lifter's big, the wheel's bigger, it will increase the duration very, very slightly. Because the wheel's bigger, it's going to open just a pinch earlier and it's going to close a pinch later. And like in the Cam Doctor, we can actually set that. We can tell it, you know, this one's using a 750 wheel or a 910 wheel or whatever we're doing. And then it'll give us that data, because for any given lobe design, you know, you can run a different wheel size. It just changes the opening and closing a little bit. And so just be aware of that. But for most of this stuff that everybody's doing with hydraulics, especially in the LS world, everybody's lifter is a 700 wheel, and it's you know, it's a moot point. On solid stuff, let me look at a master, and I'm gonna get some real numbers just so we can have something accurate to talk about. All right, so this one's designed for a 900 base circle small block Chevrolet. So this one is 301 at 20, 267 at 50, and the lobe lift is 431 thousandths. And now this is going to be run on a small block Chevrolet, which from the factory is going to be a 1.5, and that's going to give us 646 at the valve. All right, and so the same is going to hold true. If you are looking at two lobes, two cams with the same 50 and the same lobe lift, are relatively close to the same lobe lift, and the 20 is smaller, whichever one has the smaller 20 is going to be a more aggressive lobe. It's going to move the valve faster, because we only have, for instance, you know, we got 301 degrees to move this far. So if we're moving this far and we make this number smaller, this is time, this is distance. So the smaller this gets, the less time we got to move the same distance. So you can kind of think about that, and it works the exact same way with hydraulics. you can think about that in your mind, you know, as that lifter is going around that lobe, it's, you know, this way is the clock. This is the time we got, and lift is the direct, you know, the length, the distance it's going. So the less time we got to go the same distance, it's got to move faster. So, you know, and again, you can get in trouble. I have seen some stuff that is just too aggressive for a given application. A perfect example, we had a guy send in a cam that another company made, and they recommended that cam to him for his application, and he's doing it's like a drift car, and the cam is super aggressive. It's super aggressive, and it's really fast, and that's not what you want, because a drift car, you know, it's up there banging on the rev limiter all the time, and the valve train is already being taxed because the lobe is so fast, and then it's just beating off the rev limiter, and we got all kind of surging and oscillating, and it's not happy. And so in short order, it beat the lobes up, and so we got to try to fix all that and make it live in this application. But if you had, for instance, you know, a nice big block with a super rigid valve train, and, you know, shaft rockers and 7/16 push rods, and, you know, on and on and on, well, you can have a super aggressive lobe and make all that work, and it's happy and it'll make power. But for most applications, I mean, I'd say 90% of applications, you know, a nice gentle lobe that gets the job done is going to make more power than this super crazy aggressive stuff. And, you know, I get them phone calls, and, you know, oh, I want something, you know, and we don't have, I mean, we got some stuff that's really fast and aggressive for specific applications, but for the most part, everything that we've got, especially in the hydraulic profiles, all that super fast top fuel dragster, bending push rods, it's just a waste of time. It doesn't make any power. It's hard on parts. It's noisy, and it's just useless. So we just have good, stable stuff that works, and it don't beat up parts, and it makes power, and that's the simplest thing to do. And, you know, there's so many other variables in the system that worrying about, you know, how aggressive a lobe is the last thing you need to be worried about. Get all that other stuff fixed, and then, you know, once you set a couple of world records, then you can worry about that other junk. So the other thing I think that's probably, so while we're on solids, let's talk about solids. So, and we're gonna do, and I'm gonna do on the Cam Doctor where you can actually see the lobe profile and all of that stuff, because I still get tons of emails and phone calls, and people's talking about ramps, and people don't know what a ramp is. And I've done some other videos on this, and they ain't seen them, or it didn't sink in, one or the other. But in the Cam Doctor, I'm going to show you the graph, and I'm going to show you where the ramp is, what it is, why it is, and all of that, because I'm telling you, the world is confused, super confused. So wherever the lash is designed to be on your lobe, let's just say that, let's just say you got 20 thousandths lash. That's your cam card says 20 thousandths lash. That is designed for whatever rocker ratio it says. So let's just small block Chevrolet. So if we got 20 lash with a 1.5 rocker, we're gonna divide that by 1.5. So that's 13 at the cam. So the valve, the tappet has lifted 13 thousandths to take up the lash ramp in the cam. So it's done. It's done at 13 thousandths. So, I mean, that's just itty bitty. I mean, the cam has barely moved the lifter and the ramp is done. It's over with. So, one thing that I never see anybody talk about, and I see it done a lot, especially in this round track stuff or even higher end drag race stuff, people will go to really high rocker ratios. You know, it should have been a 1.7, they'll go to a 1, I mean, it should have been a 1.5, they'll go to a 1.7 or a 1.8. I've even seen some round track stuff go from a 1.5 to a 1.9. Keep in mind that when you increase rocker ratio, the lash ramp did not change on the camshaft. So if it was 13 at the cam, then you got to multiply that by your rocker ratio. So if it was a 1.5, then that would be 20. Well, if you go to a 1.9, so we just multiply that by 1.9, now your lash setting is 25, not 20. So keep that in mind when you're changing ratios, because your card is going to tell you the lash is whatever, 20 at one point with a 1.5 rocker. So, and again, as far as I know, the whole world is telling you lash hot, not cold. I get that question a lot. Lash hot, because the valve train is growing when it's hot. And that's why we need lash, because what's happening is 20 hot. Well, cold it might not be, but 10. So some of these, you know, all of this tight lash stuff that kind of is big lately. Some engines, I mean, you put 12 or 14 lash in it hot, and it'll hang the valve open when it's cold. So be aware of that. And I always tell people, especially if the cam is designed, because like most of our LS stuff is designed for 17 lash hot with a 1.7 rocker. And I tell everybody, you know, just check it when it's cold. I mean, set it when it's hot, check it when it's cold, make sure there ain't no issues, you got lash, and as long as you have some lash, it's fine, you know. And some stuff grows so much that I hear people talking about just setting it at 0 cold. And I mean, that's fine, but I would want it to be uniform, hot, and set all the lash hot, and that way we got, you know, some kind of, everybody's up to temperature and grown as much as it's going to grow. So having said that, you know, just, and I don't, again, everybody do what they want to, but we set lash, I don't know, on this bracket stuff. I mean, we'll set the lash at the beginning of the year, and we might check it 3 or 4 times over the season, just a little quick bump it and make sure nothing's obvious. Because if everything is happy, it ain't moving. It just ain't moving. I mean, we almost rarely do we have to fool with lash. I mean, it just, if you're having to chase lash all the time, something is going away. You either got valve seats going away, tips going away, you know, bearings in the wheel, a lobe or something. And all I'm ever really looking for, you know, I'm going down the line checking lash, and I'm hunting one that's obviously out of the window of the rest of them. And then we know, hey, you know, that system's got a problem. We need to pull an intake and look at a lifter, or check a stem height on the valve or whatever, because something's moving around. And that's the big deal to me. But, you know, I see some people, man, they trying to check the lash every freaking race, and they just constantly got the valve covers off. And I don't know what you're doing that needs that. And again, if it's moving around that much, something's wrong anyway, you know. So keep that in mind with the lash setting. I think, and another thing while we're talking about cam core stuff, we on that subject, keep in mind that if your camshaft needs a bronze or steel distributor gear, It also is going to need some kind of special fuel pump push rod if you're using a mechanical pump. And I see that a lot. I see cams, because we get, I don't know, hundreds of cams in here a year to regrind. And I see tons of cams, and probably most of it is in round track applications, because a lot of them have to, they are mandated to run a mechanical pump. And the fuel pump lobe is tore up where they've run a standard pump shaft on that roller cam, and you can get a bronze tip, you can get an actual roller style fuel pump push rod. So keep that in mind. There's some options there, and I think we'll call it here on this video, and then we'll dig a little deeper. And if you've got questions, put them in the comments. If you got ideas, hey, what about this or what about that? Put it in the comments, and we'll try to incorporate that in this series, because I want to hit all the high points. Because, like I say, we get these questions so much, and I think it would just be a community service to just try to put some of this information out there, so you can just go watch a video instead of sending an email or calling. And then once XYZ, then when we do talk about your cam, or you got a cam and you got a question, you got some better information to help you move forward. So hopefully all this was helpful and made some kind of sense. And like I say, be on the lookout. We're going to do at least 2 or 3 more episodes in this series, and hopefully it'll help and bring your program to the next level, I hope. Thank you so much. We'll see you on the next one.